Chapter 1, Abbreviation, Symbols, and Basic Mathematical Skills for Pharmacy Technicians. We'll skip over the keywords. We should cover them in the chapter. Pharmacology is the study of the uses, mechanism of action, and effects of medication on body systems. Chemicals used as medications or drugs are the basis of pharmacology. Medications used to treat conditions and diseases must be dosed, prepared, and administered correctly. Calculating doses correctly is essential for the safety of patients. Different medicinal preparations contain different amounts of active ingredients. Preparations also contain a variety of excipients, which are medicinally inactive substances added to the formulation as fillers, binders, coloring agents, flavorings, and preservatives. Each drug has its own specific concentration of active ingredients in a formulation. For an example, a tablet could be 10 and 20 milligram strengths and have a liquid in 125 milligrams per 5 ml and 250 milligrams per 5 ml, meaning every 5 ml the patient takes, they receive 125 milligrams. So if they were given 10 ml, that means they would be given 250 milligrams, and so on and so forth. 5 ml is also 1 teaspoon, so just keep that in mind. Knowledge of medical terminology and abbreviations is necessary for properly interpreting and dispensing prescription and medication orders. Some abbreviations that have been used for years have been found to lead to medication errors, which led to the development of the Joint Commission's official do not use list of abbreviations. To comply with that list, none of the included abbreviations have been used in this text, and we aren't going to use them except for if talking about this list. But you could see them in the real pharmacy use, because I guarantee that the doctors do not pay attention to this. So for unit, we shouldn't use U. We should write unit instead, because it can be mistaken for 0, 4, or CC. The skipping down 1 to QD, they actually recommend that you put daily or every other day instead of putting out the SIG code QD or QOD. But like I said, most prescriptions are written with QD on them. Trailing zeros are important. We would never want to write like just 0.5 milligrams. We'd want to write 0.5. And then morphine sulfate should not be abbreviated as MS, because it could be mistaken for magnesium sulfate. That's a big mistake. In addition, the Institute for Safe Medication Practices has compiled a list of error-prone abbreviations, symbols, and dose designations. So we have the abbreviations here, again, the intended meaning, the misinterpretation, and the correction. So you don't need to study the do not use list. I would spend my time studying the SIG codes, because like I said, most doctors do not pay attention to that. So for routes of administration, we have ID, which is intradermal, IM, intramuscular, IT, intrathecal, IV, intravenous, PO, by mouth, PR, rectal, PV, vaginal, SC, SQ, subQ, subcutaneous are all on the do not use list. They say to use subcut, SL sublingual, and top is topical. Frequency of administration, so QH means every hour, So just as a general rule, Q means every. So then we have every hour, every 2 hours, every 4 hours, every 6 hours, every 8 hours, every 12 hours. And then we have once a day, which is QD, which they're saying, we should use daily. But like I said, study the actual SIG codes. BID, which is twice a day. TID, which is 3 times a day. QID, which is 4 times a day. So these 4 here are really important. I mean, they all are important, but those are the ones you're going to use a lot. Every other day is QOD. Of course, that's on the do not use list. Q week is every week, and Q month is every month. Some abbreviations and SIG codes for times of administration. So AC means before meals, PC means after meals, AM means morning, PM means evening, NOC means night, HS means bedtime. ASAP means as soon as possible, and STAT means at once, immediately. For dosage forms, we have solids, which are, so we use cap and tab, and capsule. Those means capsule and tablet. So whenever you're writing out directions for a patient, we never would write take 1 tab. We would always write tablet. We would actually never leave abbreviations in directions for a patient. We never want to assume that they know what that means. For liquids, we have FL for fluid, LIQ for liquid, SUSP for suspension, and SYR for syrup. For semi-solids, we have CR for cream, LOT for lotion, SUP for suppository, UNG /oint for ointment. For our measurement systems, we have MCG for microgram, MG for milligram, G for gram, KG for kilogram, ML for milliliter, and pay attention to that L. It is uppercase, just like the L in liter. And then we have meters. For the household system, we have GTT, which is drops, TSP, and T for teaspoon, a lowercase t. So you can see where that would be kind of confusing. Tablespoon is TDSP with a uppercase T. C and C, lowercase c and uppercase C are supposed to represent cup, OZ ounce, PT pint, QT quart, GAL gallon, the pound sign or LB for pound, the quotation mark symbol or inch, the apostrophe, and then foot. And then for the apothecary system, we have GR for grain. We have for dram, this is the symbol. For ounce, this is the symbol. For minim, this is the symbol. For fluid dram and fluid ounce, that's the symbol. We will go over those more in depth. For mill equivalents, we have MEQ. The E is always uppercase. And then we have IU for international units. For ears and eyes, we have AD for the right ear, AS left ear, AU for each ear, OD for right eye, OS for left eye, OU for each eye. And then general abbreviations, an A with a line on top is before, a P with a line on top is after, a C with a line on top is with, an S with a line on top is without. Equal is equal to, a equal sign with a slash, not equal to. Less than, greater than, higher than, increase, lower than, decrease. AA with a line on top is of each. Ad lib means as desired. DAW means dispense as written. NKA means no known allergies. NKDA means no known drug allergies. Non-rep means do not repeat. NPO means nothing by mouth. OTC means over the counter. QS is sufficient quantity. Rep is repeat. RX is prescription treatment or take the drug. TO is telephone order. UD is as directed. VO is verbal order. So you can do some of these practice problems. For practice, they're not required unless that's an assignment in Canvas for you to do. The need for pharmacy technicians to master mathematical skills is important. Mathematics are used daily in the preparation of medications in both retail and institutional pharmacies. The responsibility that accompanies the preparation of medications is one that must be taken seriously so that effective drug levels are reached and dangerous drug levels are not reached. Technicians are responsible for their actions, which are heavily dependent on mathematical skills. All right. The basic fundamental math skills are necessary for pharmaceutical calculations, so nothing too extreme. We'll go over conversions and military time and stuff of that nature. So basic math skills are necessary for safe and accurate dosage calculations. Understanding whole numbers, fractions, decimals, and percentages is crucial to pharmaceutical calculations. So this is crucial to doing calculations out in the workforce and also when doing math in our program. So many of the calculations will involve properly setting up and solving ratio and proportion equations. Knowing your multiplication tables without the use of a calculator is also really helpful for keeping up with the pace in a pharmacy. So I'm going to highlight that because that's really important. If you're not the greatest with your multiplication tables, which, hey, some people just aren't, you can, maybe buy some flashcards or do some online testing just to kind of, sharpen up your skills. That will be super helpful. It says a calculator will be available, but most will make you do it without one. That's untrue, I think. You get to use a calculator on the PTCB test, and there's usually tons of calculators all over the pharmacy. So then we have the self-test of basic math skills that is not required, but we will go through some of them just to kind of refresh your memory. Okay, so we're going to do some examples from chapter 1. This is just basic math. You will use these skills to apply them to different skills as we go on through the program. But just keep in mind, there's not going to be like any questions like this specifically on the PTCB because they're not going to ask you they're not going to ask you to add fractions. They're going to ask you to do dosage calculations, which you might know fractions for to apply that into learning that. So first things first is we have 3/4 plus 7 and 7/8. So we need to take care of this first. Then we can add. So this is a mixed number. To change it to an improper fraction, which is what we need to do, we need to multiply the denominator times the whole number. So 8 times 7 is 56. 8 times 7 is 56. And then we will add the top number, the numerator, to that, and we get 63. We leave the denominator the same. And now we can do our problem. So I'm going to write it out like this. All right. So I'm going to draw another fraction bar here. So looking at 4 and 8, we need to find the lowest common denominator. So a number that will evenly divide between both of them in the lowest form. So looking at this 4 and 8, it's going to be 8. And if you're not good at doing this and you're not good at your times tables and your division, one rule I always say is try to see if it will divide into your highest number. Both numbers will divide equally into your highest number because you know that's going to put one of them at 1. So anyway, we will put our 8 here. So 4 goes into 8 2 times. 3 times 2 is 6. 8 goes into 8 1 time. 63 times 1 is 63. So now we can add, because we have the same denominator, we know that's going to be 8. And we'll add the 63 and the 6 together, and we get 69 over 8. This cannot be our answer because it's improper, so we need to turn it into a mixed number like we did here. So this is how we do it. We kind of do old school long division. So 8 goes into 69 evenly. So this is where knowing your times tables is going to be crucial. So 8 times 8 is 64. 8 times 9 is 72. So it's going to need to be 8. So I'm going to put 8 there. 8 times 8 is 64, like we said. I'm going to subtract that from the 69. And we get 5. So this becomes our numerator, the remainder. And our denominator is this number over here. So now we have the answer of 8 and 5/8. Now, if this was not down to lowest terms, we would have to change that, but it is. So that is our answer for that problem. So looking at those 4 numbers, it looks like the lowest common denominator that would work for all of them would have to be 30. That all goes in, those all go into there equally, and if it's not the lowest common denominator, we can always go back and do it. So I'm going to put 30 as the denominator for each problem. And then 5 goes into 36 times. So 1 times 6 is 6. 10 goes into 33 times. So 4 times 3 is 12. All right, so 15 goes into 32 times. 3 times 2 is 6. And 6 goes into 35 times. And 5 times 5 is 25. So we know that our denominator is going to be 30. So we just need to add up all the other numbers. 6 plus 12 plus 6 plus 25, which is going to give us 49. So we have 49 over 30, which we know we can't leave it that way. We need to turn it into a mixed number. So 30 times 2 is 60, so it has to be 1 that we would use here. 49 minus 30 is 19. And we keep 30 there. And that is to lowest terms. So for 15, we have 5/6 divided by 3/8. How we deal with division of fractions, we do keep, change, flip. So our 5/6 we keep. Our division sign we change to multiplication. And the last fraction we flip. So we take that 3/8 and we turn it into 8/3. Then we can just multiply across. So 6 times 3 is 18, and 5 times 8 is 40. So now we have 40/18, which we know we can't leave. So we would just go 18 into 40. 18 can go into 40 twice with twice evenly. So 18 times 2 is 36. That leaves 4. So we have 2 and 4/18. That 4 and 18, though, that needs to be brought down to lowest terms. So let's go into each of them and see if that brings us down. So 4 divided by 2 is 2, and 18 divided by 2 is 9. So yes. So our 4/18 is really 2/9. So we have 2 and 2/9 for number 50. So for number 16, we have 1/200 times 150. So what we need to do is just rewrite this 150/1. And then we can just multiply across. 150 times 1 is 150, and 200 times 1 is 200. We need to bring these down to lowest terms. Let's try 2. So 150 divided by 2 is 75. And 200 divided by 2 is 100. So then we get 75 out of 100, which also can be further reduced by 25. So we probably should have done 25 into each of them first. But again, you can do this if you accidentally don't pick the right number, you can just redo it. So 75 goes, or 25 goes into 75 3 times, and 25 goes into 100 4 times. So we have the answer of 3/4. Okay, so number 26 on my practice here, we have 3/4, and we need to turn that into a percentage. So to do that, we need to turn our fraction into a decimal. So how do we do that? We divide the top divided by the bottom. So 3 divided by 4, which gives me 0.75. And then I'm going to multiply that by 100. Which gives me 75. And add a percent. So 75%. 27, we have 3.5 that we need to change to decimal. So we can just do 1 divided by 2 for the fraction part, which gives us 0.5, and carry the 1/2 with the 3, so we have 3.5. Okay, so now we have 18 express 0.4 as a fraction. So I'm going to put this over 1 and multiply them both by 10. And we know we get 10 on the bottom. And 0.4 times 10 is 4. So we get the fraction as 4/10. Then we just need to divide that further. 4 cannot go into 10 evenly, so we'll do 2. So we get 4 divided by 2 is 2, and 10 divided by 2 is 5. So that is 2/5.